Solving quadratic equations with factoring. So on the left, we have a reminder of the basic steps on how to solve by factoring over here. So first of all, this is just how to factor. So we're going to factor first, and then once we have it factored, we're going to use the zero product property to actually solve it for the value of x. So if you have two things multiplied together that equal zero, then logic says, well, that means this needs to be equal to zero, or this needs to be equal to zero. And that's where we get the zero product property. So let's just go ahead and look at the first example. So what are the solutions to the following quadratic equation? So when you solve by factoring, you first have to make sure that it is in standard form, which is ax squared plus bx plus c, which in this case it is. My a is 6, my b is 7, and my c is -3. So we're going to create ourselves a little table. We're going to first multiply a and c together. So we're going to have 6, and I'm going to put the x's in here just to make it clear. 6x squared times -3 on one side. So 6x squared times -3. So 6x squared times -3 is -18x squared. So I need numbers that will multiply to be -18x squared, but will add up to the value of b, which is 7x. Okay, so just start at the top. So to get -18x squared, I would have to multiply -1x times 18x. That in fact gives me -18x squared. But if I try to add those up, -1x plus 18x is 17x, which is not the number that we need. So we try again. So then I say, well, -2x times 9x, that makes -18x squared. So let's try adding those together, -2x plus 9x, and I do in fact get 7x, which is exactly what we were looking for. So these are the two numbers that we're going to use to help us in our factoring process. What this does is this actually breaks down the b term. So -2x plus 9x. And then everything else is going to just drop down and stay the same. So we still have 6x squared minus 3 equals 0. And the reason why this works is if I were to simplify this back, I would add -2x and 9x together, which would combine up to be 7x. So that's why this works the way it does. We haven't changed anything. We've simply broken apart 7x into -2x and 9x. The next part is we're going to break this up further. So I'm going to divide this kind of in half. I'm going to just look at the first two terms, and I'm going to divide out whatever they have in common. So 6x squared and -2x, what they have in common is a 2 and an x. Now, I can't just make this 2x disappear because I didn't divide to everything. All I divided to were these. So the 2x can't disappear. The 2x has to come to the outside of a parenthesis. And then I'm actually going to complete the division. So we end up with 3x minus 1. And again, if you were to multiply this back in, you get back where you started. 2x times 3x makes 6x squared. 2x times -1 makes -2x. So you're not changing your problem. You're simply making it look different. You're manipulating. Now let's look at the other side. 9x and -3. Well, I can divide a 3 from both of those. So again, the 3 does not disappear because I didn't divide everything by 3. I only divided this piece. So the 3 is a positive 3, has to go on the outside of a parenthesis. So now actually divide. 9x divided by 3 makes 3x. -3 divided by 3 makes -1. And then we still have equaling 0. So we're getting closer and closer to our factored form. Now we're going to look at this as a whole piece. So 2x times 3x minus 1 plus 3 times 3x minus 1. And I see that these are both the same factor. So just like before, I can take that 3x minus 1, pull it to the outside, and then what we have left over is we have a 2x from the front, and then we have plus 3 from the back. And then everything still equals up to be 0. So this right here is factored form. We're not solved yet, we're almost there. We still need to get x by itself, but if you notice, now we have two items multiplied together equaling 0. So now we can use that zero product property. And the zero product property says that I can take 3x minus 1 and set it equal to 0, and I can take 2x plus 3 and set it equal to 0. Now we can actually solve these for x. Simply add 1 to both sides here, so we get 3x equals 1. Divide out the 3, and the first solution we have is x equals 1/3. Now over here, we're going to subtract 3 from both sides, so we get 2x equals negative 3, and then divide by the 2, and we get x is equal to negative 3 halves. So here are my two solutions to this quadratic equation, x equals 1/3 and x equals negative 3 over 2. Now let's look at example 2. I'm going to help you start it, and then you guys are going to work through it the rest of the way. So first things first is we have to make sure it's in standard form. And standard form is ax squared plus bx plus c equaling 0. Well, I need to move over the x and the negative 9. So I'm going to have to subtract x here. And we end up with 4x squared minus 12x equals negative 9. And then we still have to add over the 9. Now, you can do this all in one step if you are able to. But 9 does not have a like term. And 9 is actually the value of c. So we're going to put the plus 9 in the back. Now we're in standard form. Now we can clearly see a, b, and c. So now you're going to start your table. We're going to do a times c. So we're going to do 4x squared times 9, which makes 36x squared. And we need two numbers that multiply to be 36x squared, but add up to be b, which in this case is negative 12x. Now, 4, 12, and 9 do not have any common numbers to divide out. 4 and 12 do. You can divide out of 4. 12 and 9, you can divide out of 3, but you can't not divide something by all 3. So we have to leave 4, 12, and 9 the way they are. So pause the video, see if you can figure out the rest of this on your own. And here's your solution for the rest of number 2. So we ended up using negative 6 and negative 6 because if we tried 6x and 6x, we actually ended up with the wrong sign of 12. We need a negative 12, and 6 and 6 gives us positive 12. So we take both of these and flip their signs to negative. So if I do a negative times a negative, I still end up with positive 36x squared. So then we try to add them and we say, oh, there's the negative 12x that I needed. So negative 6x and negative 6x is what splits the negative 12. Then take out the common number of 2x in the front and the common number of 3, negative 3, on the other half. Then you end up with the same factor, 2x minus 3 times 2x minus 3. So when you use your zero product property, you end up with 2x minus 3 equals 0 and 2x minus 3 equals 0. These are the exact same equations. So you don't need to solve both of them. These are both going to give you the same solution of x equals 3 over 2. So when you come out with the same factor, what that means is you really only have one solution. So what your graph looks like is your graph is actually just touching the x-axis at 3 over 2. Something like number 1, where you have two unique solutions, that means your quadratic actually crosses twice on the x-axis. That's what you're finding. You're finding the x-intercepts. All right, so now look at number 3. So what are the values of x that make this equation true? So you're going to have to move things over. Now, yes, I do agree that it is easier to move one term to the right rather than move two terms to the left. However, when you factor, you need this a value to be positive. So don't move your 4x. Instead, you need to move these two to the left. That keeps the 4x squared being positive. So we're going to subtract 4x and we're going to subtract 84 from both sides. Now, there are no like terms on the left, so we're going to end up with 4x squared minus 4x minus 84 equaling 0. Before you start your table, before you start the a times c, take a look and see if you can maybe divide something out of here. So 4, 84, and 0. I can divide all of these by a 4. And whatever you do on the left, you need to do on the right. Now, we don't actually have to keep the 4. When you were just factoring, you would pull the 4 to the outside, have whatever was left on the inside. But now that we have this equals 0 part, I don't need to keep the 4 anymore. Since we're actually solving and we've divided 4 to everything left and right, we can actually get rid of the 4 now. So this 4 is gone, and this makes this that makes this an x squared minus x minus 21, and then 0 divided by 4 makes 0. So now this is what you're actually factoring. So now that we have this as simple as it's going to go, now is where you would start your a times c. So x squared times negative 21, which makes negative 21x squared. And you have to add up to be the b, which in this case is a negative x. Remember, this is your new a, this is your new b, and this is your new c. Okay? Pause the video and see if you can get this solved. If you get stuck and you're not sure where to go, then unpause the video. This may be one that is kind of weird. So this is where you stop. You get negative 1 and 21, which does not add up to what I need, negative 3x and 7x, which does not add to what I need, and then we start repeating our factors 7 and 3. So the only factors we really have are these two, and neither of those add up to the value of b that is required. And so what happens is, this is something that this is something that actually cannot be factored. Since there are no numbers that multiply to negative 21x squared and also add to be negative x, this doesn't factor. And so we say that this cannot be solved by factoring. Now, that doesn't mean there isn't a solution. There actually are still solutions to this problem. It's just we cannot solve this with the factoring method. There are other methods out there. We just have not learned them yet and put them into our toolbox. So we can't do anything else with number 3. So if you end up with something like this, where you ran out of factors and it doesn't add up to what you need, you can't solve it by factoring. You need to use something else. Right now, all we have is the square root method, which I can't use because there are 2 sets of x's. So I can't use the square root method either. We will learn how to solve these down the road. Let's look at an application problem. So number 4, what is the value of the larger base in the trapezoid below if the area of the trapezoid is 32 square units? And I give you the formula for the area of a trapezoid. So we need to figure out what we have. So I know the area of the trapezoid is 32 square units. Now that doesn't mean you're going to take 32 and square it. That's what the area is. Area is always like square feet, square inches, square centimeters. So it's just simply 32 units squared. You don't really need this piece. So 32 is what the area is. So we're going to take 32, plug it in here. So we have 32 equals, now 1/2 is part of the formula, times the height. And so the height of this is actually this x. So this is h. So 1/2 times x, and then times the addition of the bases. So we're going to call base 1 this guy. So we're going to take x plus 2 for base 1. And then also this guy will be base 2. So plus base 2, which is x plus 6. Now, before you start trying to solve this, let's make this simpler because that looks really, really crazy. So start at the inside. X plus x makes 2x, and then 2 plus 6 makes 8. On the outside, 1/2 times x is just 1/2 x equals up to 32. And I can make this even simpler. 1/2 x times 2x is just an x squared. And then 1/2 x times 8 makes a positive 4x. This is getting closer to something that I'm used to. Well, solving this, I need everything to one side. So I'm going to subtract 32 to get it into that standard form because I'm trying to solve by factoring. So we've got 0 equals x squared plus 4x minus 32. This is what we're going to have to solve. So really, the only difference between this example and the ones that you've seen before is you had to come up with this guy on your own. You had to use the area formula and substitute the values. So the height, base 1, base 2, and the area, and then manipulate it down to something that you can actually factor. So let's put that over here at the top. 0 equals x squared plus 4x minus 32. So this is what we're trying to factor out. So here's A, B, and C. So we're going to use our table. So A times C, which is x squared times negative 32, which gives us negative 32x squared, And we need two numbers that multiply to negative 32x squared and add up to be the value of b, which in this case is 4x. So let's run down our list. Take a minute and try to see if you can find those two numbers. Hopefully you should have stopped at negative 4x and 8x, because if you add those together, negative 4x plus 8x, there's the 4x that we need. So these are the two numbers we're going to use to split apart b. So now we've got 0 equals x squared. 4x gets split apart into a negative 4x plus an 8x, and then you still have minus 32. Now to continue the factoring process, divide it in half and look at the first two only. X squared and negative 4x only have an x in common, so we end up with x minus 4. 8x and 32, negative 32, have an 8 in common, so we're going to pull that to the side, and we end up with x minus 4. And then we see that the x minus 4 is common on both, and so we're going to pull that to the side. And what's left over is the x plus 8 from the outsides. And all equals 0. Now that's just solving it. We got to factor it now. Or we actually, that's just factoring. We have to solve it now. We need to split this into the two equations. 0 equals x minus 4 and 0 equals x plus 8. Solve both of these to get 4 equals x and negative 8 equals x. Now, normally we would stop here and say we're done, but because this is application, you need to think about the reasonableness of your answers. First of all, we wanted to know the value of the larger base. So I want to know what this value is here, because x plus 6 is the longer base. Okay. Now, here's another issue. If we try to use both of these, so for example, if I use negative 8 and you put that here for height, well, that would give me a height of a negative value. You can't have a negative length. It's not reasonable. So this isn't even really a solution because you can't have a negative value for a height, a length, a base, a volume, none of that. So really the only value of x that works is 4, but 4 is not your answer because I want the value of the larger base, not just what x is. So the value of the larger base is actually x plus 6. And I know that x is 4. So to figure out the value of the larger base, we're going to take 4 and add 6. So the value of the larger base is actually 10 units. It doesn't tell me what kind of units, so we're just going to say 10 units. So the solution to the quadratic equation was 4, but the solution to this question is 10 because it wants the larger base and not the height. Number 5 is very similar. What is the value of x for the rectangle below if the area is 26 square units? So again, I give you area. Now the area of a rectangle is length times width. That's the area of your rectangle. It doesn't matter which one you call length and width, just make sure one's length and one's width. So pause the video, try to find your quadratic that you're going to be solving first. We'll do this in pieces. So pause the video, plug in what you know, and get it simplified, and then unpause. So here's the quadratic that we are going to be solving. Area was 26, length and width multiplied together. Multiply this out, and you end up with 2x squared plus x minus 36. So I'm going to rewrite that up at the top so that I've got space to work. And now is where we're actually going to start solving by factoring. So A, B, and C, and create your table. A times C, 2x squared times negative 36, which actually ends up making negative 72x squared. And we need two numbers that will add up to be B, which in this case is just a 1x. Pause the video, see if you can find your two numbers. And you should have had negative 8x and 9x to be your two numbers. So now use those to split apart B, like this. And now's where you're going to continue factoring. You're going to split this guy in half, look at the first two only, and then the last two only. So see if you can figure out the value of x. Pause the video and finish solving the problem. And here's your solution to example 5. So you should have only come out with x equals 4 as an answer. We had to reject x equals negative 9 over 2 because, again, if you plug in negative 9 over 2, let's say to this side here, negative 9 over 2 minus 2 will actually give you a negative value for this length. So it's not the fact that it's a fraction. Fractions are fine. If you had a positive 9 over 2, that would have been a very different story. but because it was negative, it actually creates a negative length value, so we have to reject this as a possible solution, leaving us only with x equals 4.